This tutorial is about adding reinforcement. We're going to start with the file that we created in the tutorial introductory RAPT run. Let me open that. Okay, and we're going to now go into input here where we see reinforcement, and there are three input sections to look at: general, design zones, and user defined. I'm going to start with general. General defines the defaults that will be used in the design zones for RAPT and when it calculates crack control reinforcement. So it will always default to this maximum bar spacing and this minimum bar spacing. If RAPT ever comes up with a bar spacing that is less than this, it will tell you, and then it will add reinforcement, for example, for crack control if it finds that it cannot achieve those spacings. Minimum continuous reinforcement is the minimum area of continuous reinforcement in the face of the member in a span as a fraction of the maximum area of reinforcement in that face in that span. So it's essentially the minimum reinforcement you want to see in any given face as a percentage of the maximum reinforcement on that face. The minimum span reinforcement into an end support is the percentage of reinforcement you want to extend into the end support. The internal support is the same thing, but for an internal support. Infill bars, these are where RAPT does not require any design bars, so there are no bars designed in a particular area, but you would like some infill bars there to tie to around which you can put ties, so in other words to support ties. You can also select if you would like to stagger the bars, if you'd like a more economical design, as bending moments taper off. So you can select these on or off if you like to, for both support reinforcement and span reinforcement. Up at the top here is shear design, sorry, not just shear design, flexural shear and punching shear defaults. These are just the defaults for the grade bar that you want RAPT to design with. So flexural bar, RAPT will design using 500 MPa, but you can choose anything you want if you want RAPT to use that. Similarly with mesh, shear option 1, 2, and 3 are more clearly understood when you see the video for output, because when the bending moments and the flexural design and shear design is shown in the output page, the shear design shows you three options for shear spacing with different bar sizes and different number of legs as you decide, and it will tell you the spacing for each of those combinations or each of those options that will lead to satisfying your shear design. And finally, punching shear. RAPT will also tell you how much reinforcement you need for punching shear based on these defaults. That's it for your general options. We now go to design zones. Design zones are the zones that RAPT will design reinforcement for you. You essentially set the position from one column to the next, and the cover. You set the maximum bar size, the minimum bar size, and your preferred bar size. And RAPT will then design reinforcement in those zones, trying to use your preferred bar size. But if it can't meet that, it will use either the smaller or larger bars within these limits. You can set a minimum number of bars if you want RAPT to use those, and you can set a maximum spacing for those bars if you want that. You can also set a minimum percentage steel as a percentage of the total concrete area, and you can set the percentage of bars you would like in the flange. That has an impact on your shear calculations because the number of bars inside the ties, and in other words, not including the bars in the flange, are what are used as your steel reinforcement for shear calculations. You can also put in a bar stagger at the left and right ends, or ask RAPT to put in a bar stagger for you, and you can define that number. And you also define your cover. So at the moment we've got 40 millimeters cover. That cover applies to the preferred bar size. If RAPT comes up with a design where the reinforcement is potentially smaller, so say you've got 28 and RAPT comes up with a design for 20 mils, a 20 mil diameter bar, it still maintains this cover of 40 relative to a 28 mil bar. So once RAPT has given you a potential design, you must enter that as user-defined reinforcement, and I'll go into that in a sec, it'll make sense, and adjust your covers to suit the bar that you're putting in. Okay, you can set up different design zones, so we can add in a design zone at different sections with different preferences, and we can split them as we like. So for example, if I add in a top zone, and let's say we're going to make it from column 3 to column 6, you can see that now RAPT has added another design zone to the right. So there are now 2 design zones, and you can have different preferences within each of those design zones. When RAPT designs the reinforcement, this doesn't mean that RAPT is going to design one continuous bar right along the top. It's just a zone in which RAPT will design it. So for example, in this zone on the right hand side, RAPT will put in top reinforcement, but only over the supports. It won't add reinforcement all the way across here, unless of course you have asked it to do that in the general tab under minimum continuous reinforcement. Now we don't need 2 separate zones, so I'm going to make it back to 1, and as I said before, that doesn't mean that it's a continuous bar. It means that RAPT will design to those preferences wherever reinforcement is required along that zone. The same goes for your bottom reinforcement, so no different there. When RAPT designs the reinforcement, it will tell you what the required development is at the end of the bar. So it may say to you that there is 0% development required. In other words, you can put the bar there and the bar will develop gradually over the length. Or if it says that you need to have developed, say, 50% at this point, then that means you must put a cog in at this bar location. That'll make more sense when I go into user-defined reinforcement, which is here. Now this is reinforcement that you define in the frame, and this is reinforcement that we had put in as part of our introductory RAPT run. You may remember that we put this in by clicking this button up here, which was Insert Design Reinforcement Pattern. The way that worked was we ran a RAPT run, RAPT designed reinforcement according to the design zones, and we wanted to see what that meant if we adopted that reinforcement pattern for deflection. So we click this button here. It puts that reinforcement that RAPT had designed as user-defined reinforcement, and the output now is for deflection is now a reflection of this reinforcement layout. So I might remove this, or in fact I'll keep this here. It's a good way to describe each of these headers. So we've got our steel type, which you can choose any steel type you want, anything that's defined in the materials section, and you may remember that you can change the materials to suit. If you have some historic grade that's not listed here, you can add that yourself. You select the column over which the reinforcement is being added, the dimension to the left of the column, the stagger, which we've got none here, but you see if I add a stagger here of 300 millimeters, RAPT will add a stagger here. And that is basically 50% of the bars being dropped off. Cover to your reinforcement. This is your development at the left end of the bar. So we are saying that there is zero development at this point, and then the bar will develop from this point going to the right until it reaches full development at whatever length would be appropriate for a 16 mil bar. Now you can say to RAPT that you want to assume that it's fully developed in this location. Now if that was the case, you would need some sort of headed anchor that would give you full development. Or you might say you want 50% development at that end, in which case you must ensure when you detail your drawing that you've got a cog there. Of course, depending on the code that you're using, that's for AS 3600 I'm talking about. And the same thing goes for the development of the end of the bar in compression. So we've got tension here and then compression next to it. Now we talk about the where the bar finishes, and then how far to the right of that bar we want the bar to extend. Now, as we explained for the left-hand side, we have a bar stagger length at the left-hand side and a cover. We do the same thing for the right-hand side, similarly for development in tension and development in compression. Then we enter the bar size that we'd like and the number of bars. You don't have to put number of bars, you can add a spacing, and if I add a spacing here, you'll see that the number of bars disappears because the spacing is what governs the number of bars, depending on your panel width. We now can put in what percentage we would like in the flange, and then whether or not this is a layer that we are attaching after the pre-existing load case. So this is where you might be strengthening a beam that has or a frame that has already been built, and you're strengthening it with this particular reinforcing bar, although it would probably make more sense if that was carbon fiber strips, where you would add the carbon fiber strip. You would probably have zero cover here and zero cover here, your carbon fiber thickness, the number of layers, and you would adjust your cover actually to suit that number of layers, and you would then select a tick here to indicate that that's added after this beam was originally formed and built. Okay, we don't need any of that, and so we'll undo. And that is it for user-defined reinforcement. As I said, the important thing here for reinforcement is you might get RAPT to design you some reinforcement, and so we can remove all bars here, which we'll do. I'll remove all bars here, which we'll do. Delete bar. We'll go to output and we'll see what RAPT designs for us. So you can see it's added this reinforcement pattern. It's not the only solution to the minimum areas of reinforcement that RAPT is requiring, but it's a solution. If we go to deflections, deflections are based on the minimum areas of reinforcement that RAPT has designed. But that is not what this reinforcement layout shows. This reinforcement layout shows a little bit more, because obviously you can never put in an exact amount of reinforcement at each design point when you've got a bar of one particular size and number. So if we go back to this deflection and say, for example, we see this deflection here is 17.4 and 25.9. If I go back to reinforcement and I add the design reinforcement that RAPT had determined in that run, and we now do the same output, we can see that the deflections have changed considerably, because RAPT has now calculated that deflection based on that specific reinforcement, those specific reinforcement areas, not on the minimum design reinforcement areas. So there are now locations in your design, if I go to Ultimate Design and Graphics, where I've gone to the wrong one there. If you go to Flexural Design, Ultimate Graphics, where RAPT now has final reinforcement and initial is the same, final initial is the same. These these capacities exceed the design reinforcement in most of the areas, because we've got a bar that extends from this end to this end. And if we went back to the previous design where RAPT had designed the reinforcement, but we hadn't added it as user reinforcement, we would see this blue line would follow this ultimate bending moment line. And that is what deflection would be based on. Now that we've got the reinforcement defined as user-defined reinforcement, and it extends this length, then you can see how that would improve your deflections. So that is it for user-defined reinforcement.